Hey everyone, and welcome to the internet. What we're going to be doing in our triple chemistry lesson this morning is having a look at titration calculations. So the end goal is to be able to calculate the concentration of a solution from the results of a titration. To start us off, what we've got are a couple of questions. Some useful atomic masses are given to you there. So I'm only going to give you a couple of minutes to get that done. So see if you can answer those in your book. Off you go. Okay, so for question 1, the relative formula mass of sodium hydroxide, we just add those atomic masses together. So 23 plus 16 plus 1 gives us 40. Give yourself a tick if you got that right. And then to calculate the amount in moles, we need to do the concentration times the volume. Again, give yourself a tick if you got that right. Let me know in the comment box how we actually did. Now, the key thing we really need to know for this entire lesson is the formula we've got on the screen here. So the amount in moles is the concentration in moles per decimeter cubed times the volume in decimeters cubed. And I've given you the triangle as well. So make sure you've got that written down. I'm just going to give you a few more seconds to get that finished in your books. So when we've actually carried out a titration, and my groups, I know we literally just did that before schools broke up, then what we've actually got are a few very important bits of information. First of all, we know the two reactants that we used. Secondly, we know the volume and the concentration of one of those reactants. And finally, we know the volume of that second reactant. The only thing missing is the concentration of that second reactant. And what we can actually do is use all that other information that we've got in order to actually calculate that concentration. And that's what we're going to be doing in this lesson, is learning how we can do that. So if you haven't already got these points written down, then obviously pause the video just to finish it off. I'm just going to give you about another 10 seconds before I move on from this bit. So what could this question look like on our exam? Well, here's our example, so I'd suggest we jot this one down, unless of course you've already grabbed the PowerPoint off my website. So 25 centimeters cubed of 0.1 mole per decimeter cubed sodium hydroxide was titrated with dilute hydrochloric acid. The mean titer of the acid was 20 centimeters cubed. Calculate the concentration of the acid. And then we've got the balanced symbol equation underneath. Now what you'll find is that bit at the top is going to stay there as we go on to the next slides as well. So even if you don't have it just yet, don't panic, it's not going anywhere. We're just going to have a little look at the next stages. So make sure you've got that example written down or you've printed it off from the website so that you can see what we're doing. Hopefully we all know, and I know that lots of you in my group are really good at this now, is that the first thing that we do when we see a question is a calculation question, is we underline, circle or highlight the key bits of information as we read it. That just means that we're not having to keep going back over and over reading the whole thing again when we need to find just that key bit of information. If you've highlighted, underlined and circled, it just draws your eye straight there. Now in this case, because we've got two different chemicals, I've used the two different colours. So I've just used red for our alkali and the green for the acid there. So all I've done is just highlight that key information for us. When we come to do these calculations, the most important thing that I will stress to you is show your working. Do not just work it all out on a calculator and then just stick an answer on the answer line, because you can make a mistake so easily and then lose all of the marks. If you've set your working out nice and clearly on the page, even if you miss a 0 or something really silly in that final answer, you can still pick up pretty much every other mark there. So the first thing we actually need to do then is, if we look at the question, we can see that our volumes are given to us in centimeters cubed. Now, when we're actually doing these calculations, we need them in decimeters cubed. So we need to convert those centimeters to decimeters. So that's step one, is our conversion. And the way we convert centimeters to decimeters is we divide by 1,000. So you can see there the volume of sodium hydroxide, we can see in the question, was 25 centimeters cubed. So 25 divided by 1,000 gives us 0.025 decimeters cubed. Do the same with the 20 centimeters cubed of acid, then 20 divided by 1,000 gives us 0.02 decimeters cubed of our acid. So make sure you set that out nice and clearly, because that conversion can actually be worth a mark for us in this question. Step 2 then is where we need to calculate the amount of the reactant that we've got both the volume and the concentration for. So in this case, we've got the volume and the concentration of the sodium hydroxide. So we go back to our formula I said was critical to this lesson. So amount is concentration times volume. Write that down first of all, so you've got it there. Then what we've got is a concentration and a volume in the question, the bits in red, so we can substitute them in. So our concentration is 0.1 and our volume in decimeters cubed, remember, is 0.025. So 0.1 times 0.025 gives us 0.0025 mole. So that's our amount in moles of sodium hydroxide. Now you'll see how I've set that out nice and clearly in that space. Please get into the habit of doing that for your actual exam answers as well, because if an examiner finds it dead easy to work out how you've sussed out the actual question and you've shown your working nice and clearly, they can find your marks easier. So make your marker's job easy to make sure you don't inadvertently lose a mark. The third stage is where we need to use that balanced equation, because what we've now got is the amount in moles of one of our reactants, and we need to know the amount in moles of the other one. Now, the balanced equation tells us this, because remember, the balanced equation just gives us the ratio of reactants to one another. So what we can see there in our balanced equation, there's no numbers in front of our formula for hydrochloric acid or sodium hydroxide. So that means there's just 1 mole of each. So we've got 1 mole of hydrochloric acid reacting with 1 mole of sodium hydroxide. Now, we've just worked out that actually we had 0.0025 moles of our sodium hydroxide. So applying that same idea of proportion, then we must have 0.0025 moles of hydrochloric acid. Because if 1 mole reacts with 1 mole, 0.0025 moles must react with 0.0025 moles. So we're just matching here. There will be some instances where it won't be 1 mole to 1 mole, but in that case you'd either just multiply or divide the amount in moles you calculated by that other number. And we'll have a look at a different example in a moment that shows you that. So make sure you've got that little bit written down if you haven't already, and remember you can pause the video if you need a little bit more time. The last thing we need to do then is go back to that formula that we used at the beginning, and we're going to rearrange it this time to find our unknown concentration. So hopefully we do know that we can use that triangle method, so you cover up the thing you want, in this case the C, and that gives us N divided by V, so the amount in moles divided by the volume. So write down that formula again just so that we can show how we're going to do it. Then we substitute in our values. So the amount in moles of our acid is 0.0025, and we divide that by the volume of our acid in decimeters cubed again, remember, which is 0.02. Put that into your calculator and we end up with our answer of 0.125 moles per decimeter cubed. So what we're actually doing here is using that one formula twice in 2 different ways. So you've got to be able to rearrange it. And if you're not good at just natural rearranging, then use the triangle method. It's absolutely fine to use that to actually rearrange these formulas if you're not overly confident with doing it any other way. And that's it. So only those 4 steps that we need to work through in order to work out our unknown concentration. So it's not really that complicated. It's just remember those 4 stages and work through it one step at a time, showing you're working. We do have a second way that we can actually do this, that some of my students have found more kind of student friendly in the past, which is to use this table I've given you at the bottom. So I've given you a different question here, so again, jot it down if you've not already got it, otherwise grab it off the website and then you can obviously just work through it there. Now what we've got here is 25 centimeters cubed of 0.4 mole per decimeter cubed sodium hydroxide was titrated with dilute sulfuric acid. The mean titer of the acid was 10 centimeters cubed. Calculate the concentration of the acid. And again we've got our balanced symbol equation there for the reaction. So at the bottom you can see this table. Now quite simply it's just got the 3 key columns from our formula. So volume, concentration and amount. On the left hand side you can see we've got the acid and the alkali, and then we're just going to fill out the information we've already got in the question here. So in the question we can see that our acid had a volume of 10 centimeters cubed, so we can put that into that first box, and our alkali, the sodium hydroxide, has a volume of 25 centimeters cubed, so we can fill in that into the table as well under the volume for the alkali. We've also got the concentration of the alkali of 0.4, So we can put that in our concentration of the alkali box. And that gives us all of the information from the question in one easy to read table. It also highlights the fact that for the alkali, we're just missing one thing, which means we can calculate that one thing. So just like before, what we're going to do is convert any of those volumes in centimeters cubed to decimeters cubed if we need to. Now in this case, we're given our volumes in centimeters cubed, so first thing we do is divide each of them by 1,000, and then we can write into our table the volumes in decimeters cubed. So you can see there 10 divided by 1,000 for our acid gives us a volume of 0.01 decimeters cubed. And then for our alkali, it's 25 divided by 1,000 gives us 0.025 decimeters cubed. So what we've done there is just the same as the other method. First thing is to convert the volumes to decimeters cubed by dividing by 1,000 if they're given to us in centimeters cubed. So we filled out our volumes now in the correct units. Now, as we've just said, we can see really easily that the alkali is only missing one thing. It's only missing the amount. Now, if we remember our formula to work out the amount in moles is the concentration times the volume. We've got a concentration, we've got a volume, so all we actually need to do there is multiply them. So concentration times volume, 0.4 times our 0.025, and fill that in our table for us under our alkali and amount section. The next thing we need to do is go back to our balanced equation to work out the amount of our other chemical. Now in this case, if we have a look, our acid, is H2SO4 and the alkali NaOH. So we've got 1 mole of our acid reacting with 2 moles of our alkali. We've just worked out that actually we've got 0.01 moles of our alkali. So obviously we've just said that we've got twice as much alkali as we do acid. So we need to make sure that stays in the same proportion. So if we've got 0.01 moles of alkali, we need to divide that by 2 to get the amount for our acid. So 0.01 divided by 2 gives us 0.005 moles of our acid, and we filled that in to the amount column for the acid on our table. Because we've only got that one box left for the concentration of the acid, then that shows us we need to work that bit out now. So we go back to our formula once more, and we need to rearrange it for the concentration. So remember, concentration is the amount in moles divided by the volume. So our amount in moles is 0.005, and we're going to divide that by the volume, which is 0.01. Put that into your calculator, and what we end up with is a value of 0.5 moles per decimeter cubed. And that's it. So what we've seen there are the two different ways that we can actually calculate our final concentrations of an unknown. So it's the same steps, whichever method you prefer, whether you like the table or whether you prefer just showing it step by step in your answer space. But the steps are the same. Now, the first thing you really got to get your head around is learning the formula. And once you've got that, then learn those steps. So to help you out with learning those steps, here's a summary with the formula in the bottom corner for you as well. So step 1, convert your volumes to decimeters cubed. So if they're in centimeters cubed, we divide by 1,000. Step 2, calculate the amount of the reactant that we know both the volume and the concentration for, and we use our formula there. So to calculate the amount, it's concentration times the volume. Step 3 is we used our balanced equation to work out the amount of the other reactant, because remember, we can see is it 1 to 1, 1 to 2, whatever it may be, and then keep those proportions the same and apply that to the amount we just calculated in 2. And then finally, step 4 is we use that same equation to work out the unknown concentration. So concentration in that case is the amount in moles divided by the volume. So those 4 stages are going to help you to solve any of these titration calculations. So I'll just leave that up there for another minute just so you can make sure you've all got that written down, highlighted, stuck in a box, something to really make it stand out as important, alongside the formula in the bottom left corner, which again you're going to have to learn because they're not necessarily going to give it to you on the exam paper. So I'll give you a minute just to get those points written down if you haven't already. Last thing for today then, have a go at these 2 questions. Now remember what we've said, those 4 stages, and show your working. By all means use a calculator to do any of the calculations, but write down each step so that we can see where your thinking came from. So have a go at doing those. I'll leave those on the screen for about the next 5 minutes so you've got a chance to have a go. As always, if you want to have some more practice, then there's some additional questions over on my website. The link is on the screen there for you. And we've also got the answers to the plenary questions that you've got there as well. So I hope you all found it useful, and I look forward to seeing you all again next time. Don't forget to check out the timetable on my website as well, so you know what's coming up and what time we're on. See you next time, folks.